Welcome to the BSides Hardware Hacking Village Lab number 5. This lab is part of the Learn CircuitPython using the Adafruit Trinket series. So in this lab, we're going to work with the dot star RGB LED and a touch sensor within the Trinket circuit environment. So we'll build that out. We will start by soldering up a circuit and then write 4 different pieces of code to interface with that circuit. So the first piece of code is going to just do a blink but with the dot star LED. The second code will do a color cycle with that LED. Then we'll start to work with the touch sensor, and we'll use the touch sensor to control an external LED. And then use the touch sensor to color change the dot star LED. So let us get started by checking out our circuit. Here we have the schematic for the circuit that we're going to build. Oops, no we don't. Here we have the schematic for the circuit that we're going to build. It is a single LED, a resistor coming off of one of the digital pins on the Trinket, and a bare wire coming off the pin that we're going to use for touch. That bare wire is not run to ground, and it's just there for us to be able to input a capacitive touch without having to jam our fingers onto the Trinket where we might short out the other connections in the process. So we have a 100 ohm resistor coming off of digital pin 2, and then that's going to lead into the anode of a 5 millimeter LED, and then its cathode is going to come around to ground. The physical connections that we're going to be working with are on the strip board that was provided in the kit. We're going to wire this circuit up with the strip board connection details that are shown here. So the Trinket should already have its header pins on the board if you did the previous lab. And so we're just going to be adding that 100 ohm resistor and the LED, and then 2 pieces of wire, one of which has been stripped bare. Now this particular set of code is going to need library files. So as soon as we're done soldering up, we will come back to this and we'll add our library files to our Trinket and start working with code. But let's get started with soldering. So here we have our Trinket, which I'm going to set off to the side. And we have our strip board, which has all the Arduino components on it, as well as the components from the previous Trinket lab that we did. And we're just going to add components to this to finish the build out. And what we're going to add is, like I said, there's the 100 ohm resistor, there's our LED, there's a short piece of wire that'll take that to ground, and then we have our bare wire that I stripped all the plastic off of. And so we will start with our resistor. Now the resistor is going to go into ports K20 and O20. So if we look, K is right next to the header. And if we match that up to 20, looks like it's about there, the middle port. And then O20 is the first section of the next strip. Bend those wires out. Then we'll get our resistor. Now the resistor anode is the longer pin and the cathode is the shorter pin, which corresponds with the flat notch on the resistor, or I mean on the LED. And so we want that LED to go in with its anode closest to the resistor in this case. I gotta bend these out a little. Okay, and so those are ready to solder up. So what I am going to do though is put something under here to prevent it from dropping down, because that LED wants to go all the way to the board and I don't want it going all the way down, so I'm just going to lay this on top of something that'll hold it up. And let us solder these connections and move on to the wires. Guess I should have checked. Yes, it's on. Tin the tip. Okay, those look good. Now we'll trim our pins off so they're not in our way. Okay, and the next thing we're going to do is take this piece of wire, and this is just straight black wire that I already pre-trimmed the ends off and bent to size, and we're going to connect it into R20 and then the VCC line that's on 20. That's this far pin here. And once again, I'm going to set this on something so that it will hold while I solder it. And of course, that didn't work. Let's try that again. Okay, let's check those out. And this one on the end could use a little more. Alright, so we got our wire in place. We're just going to trim the ends. And then all we have left is the bare wire, and we will start writing code. Now for our bare wire, we're going to put that between K19 and O19. And we want to bend it into a U shape between the two. That way it's a nice touch point. Let's see. Bring it a little closer. Yeah, right there should do nicely. Let's get it in place and bend the wires out so that they don't move. That should work. That looks pretty good. Looks like I bent my LED down there. Bend it back up and trim these wires, and we are done. So we'll just plug our trinket in, and we'll be ready to load it up. And to plug in the trinket, I'm using the safety USB connector, which is always important, so you don't damage your PC if something went wrong. Okay. Put this up here out of the way. And we will go back to our presentation quickly. So we talked about library files. We're going to be working with the dot star RGB LED, which is on board the trinket. But its library files are not built into the CircuitPython code. So what we have to do is copy the files over that we require. So what we'll do is download the CircuitPython library, if we don't already have it, from circuitpython.org/libraries. And then we're going to unzip that or extract it to someplace on your PC. You're going to find these two files, Adafruit_.star and Adafruit_py_pixelbuff. And then we're going to copy those into the lib directory on CircuitPy. So if I show you my CircuitPy drive right now, the lib directory is completely empty because when I did the firmware upgrade, it removed all the incompatible library files. So now we're going to copy over to this directory. And I can do that just from Explorer or from a command line. So I already downloaded the 5.x bundle, and I have moved into that directory, and you'll see there's two subdirectories once you extract it, examples and lib. And if I go into lib, you'll see there's a whole bunch of files there. Most of them start with Adafruit. So if I look for that specific file, We'll just look for the dot star one. And we see it's right there. So let's copy it first. So we're just going to copy this file to my drive is E. So I'm going to go to the E drive and I'll put it in the lib directory. And then the other file that we needed was py pixel buff. And we see it's right there. And so we're going to do the same thing for that and copy it to my lib directory. Now if I look in Explorer here, we see that we have the two files that we're going to need later. So now we're going to move on to checking out our code, which will use these files. And the first piece of code that we're going to look at is going to blink the onboard dot star LED. Since this is a red, green, blue LED, it's actually going to flash red, then green, then blue, and then go to sleep. So this is going to work a little differently than our other LEDs that we've been working with because of the type of LED this is. This is an addressable LED, similar to a NeoPixel. So we're going to load the library for it, that Adafruit dot star library. We're going to load it and we're going to change its name as we do that. We're going to call it dot star just to shorten the name as we're working with it. And then we're going to create an object called dot. And we're then going to take that dot object and we're going to assign it the dot star pins. Now, in the documentation, in the pinout for the Trinket, it says that the dot star uses pin D7 for data and D8 for clock. However, we're using this board library, which the board library assigns those pin names into things that we can use here. And in this particular board library, it's not recognizing D7 and D8, but it knows those same pins by these names, the APA102, SCK, and MOSI. And so we're going to define those as the pins. They are the same pins as the documentation shows as D7 and D8. So we're going to give it its data pin. We're going to give it its clock pin. We're going to tell it how many dots are in this because just like NeoPixels can come in strings, so can dot star LEDs. This is an onboard one that's a single one, so we're telling it there's only one. And then we're going to tell it the brightness is 0.2. So that's about 20% of the brightness because those things do get quite bright. In our main loop, you'll notice that we're assigning the dot values differently than we did the LEDs. So first off, the dot object is assigned like an array. You'll notice it's dot with the square brackets around 0 because it is an array. It's that object is being called, can be an array of many different dots. We're just happening to work with one, so we're going to call it as dot 0. And instead of just giving it a value of what we want to set the light at, because it has three different LEDs built in, red, green, and blue, we have to provide it a list. And that list is going to have three values, the red value, the green value, and the blue value. And their value can be anywhere from 0 to 255, 0 being fully off, 255 being fully on, and the numbers in between being the in-between states of on and off for each of those. So for our code, we're going to set this first value as 255, 0, 0 as the list that we send it. And then we're going to go to sleep for half a second before we go on to the green. And you see the green value is set. We sleep. We set the blue value, sleep, and then we set them all off with zeros, and then we sleep. So this way of sending a list into an object that's an array is how we will work with the dot star and setting the red, green, blue values. So let's take a look at that code on the actual board. So first I'm going to open up my editor. And here we have that same code we just walked through. I'm going to select all of this and copy it. And then I'm going to open up the Mu editor because that's going to pull up the code that's currently on the board, and I will just copy it into there. So what we'll have is this is the code that's running now, and I'm going to select it and replace it with my code. And then I'm going to save. And we'll look at the serial output, which we're not printing anything to serial, so I didn't expect to see anything there. But if there was an error, it would have shown up here. And so what we can see in on the board itself, off to the top left corner here, we can see it flashing red, green, blue, and then turning off, red, green, blue, and repeating that process. So this is telling me that our code is running. Now, because we're actually using the dot star LED in our code, the normal status that is shown on it, which would have been solid green for it running code, that is being overwritten by what we're doing. So that's why it's not displaying those status codes, because we're using that for another purpose. Okay, so now let's take a look at our next piece of code. So the next thing we're going to do is to color cycle the colors on that same dot star. So the import is the same and the assignment is the same, but we're going to define a function. And I'm just going to go ahead and open up my version of code with that because it's a little easier to read. So yeah, our function, we're calling it wheel, and it's going to take an integer here that we're assigning as POS, and that's our position in the loop, I think. And this function I stole from the demo code that runs on the Trinket. So this is not my code, but it's code that works, and so I grabbed it for this example. And basically what this function is going to do is when we call it, we're going to give it a single integer number. And it can handle any integers because of this part of the code here, handling if it's less than 0 or greater than 255, but it's expecting to see a value between 0 and 255. And then based on that number that it gets, it's going to use that to do some quick math and come up with what the actual R, G, and B values should be and return them. So I'm not going to get into all the math here, but it is kind of cool if you want to take a look at that and how that's working. But it's basically moving the colors in a cool way. And so what we're going to do is in our main loop here, well, first before our main loop, we set our iteration variable. This is 0 right now, and it's I and it's set to 0. And in our main loop, what we're going to do is set .0. Its value is going to be the wheel function. We're going to actually call the wheel function, and we're going to call it with I, which starts as 0. And then we're going to add 255 to I. And when we send it through here, it will return a list, an RGB list that is similar to this. And it will have values in there based on the red, green, and blue. And then once we set that, we're going to iterate I and send it up by 1, making sure that it doesn't go over 256 so that this keeps it running between 0 and 255. and then we will go to sleep for a little bit before it does the next color. And this is a very short sleep time. But this way it spins through the colors fairly quickly. So that will be the next piece of code that we run. Let's go back to our Moo editor, and we'll paste it in here. And we shouldn't see anything in serial, but what we're seeing is it is slowly cycling through the colors now, going from one to the next and mixing them together in like a round wheel of colors, which is kind of cool. So that's exactly what we wanted it to do. And let's look at the next piece of code. Okay, so our next piece of code is going to utilize the touch sensor and that other LED that we wired onto the board. And what we're going to do with that is we're going to read in the touch as an analog signal and then make a decision based on that. So for this to work, we need a different library, the touch IO library, which this particular library is part of the built-in libraries in CircuitPython. We're going to assign an object called touch to the touch-in analog pin on A0, A0 being an analog assignment port that tells it we want an analog input. So we don't have to set the direction on that. We do set up our LED as a digital in-out, and we set the direction of it as output. And then in our while loop, the first thing we're going to do is read the touch value. So we're going to make a variable called tval, and we're going to read in the touch raw value into that variable. And we'll go ahead and print that to serial. And then we make a decision about if a conditional if tval is greater than 3500, then we're going to print off that it's been touched, and then we're going to turn the LED on by setting the LED value to true. Otherwise, we're going to set the LED value to off. And then we're going to sleep for about 1/5 of a second and go through it again. So now the touch value being an analog signal, it's constantly going to have values on it. It's not going to drop to 0. We did not do any kind of pull down to pull that down to 0. It's just a raw wire hanging off there, and it's going to be sensing various capacitive values in the capacitive touch sensor. So what we have to do is look at what are the capacitive values that it has during its normal ambient state when it's not being touched. And then what do those values normally go to when we do touch it? And that's why it's important to show the value in the serial output. That way we can adjust that 3500 number. So what I found when I was looking at this was most of the ambient values were 2000 or less, and when you touched it, it usually went over 4000. So I figured if it's over 3500, that's a guaranteed touch. But we can adjust those values based on looking at the serial output and seeing what is the sensor seeing when I'm not touching it, and what does it see when I touch it, and then we can do conditional code based on that. And it doesn't have to be lighting an LED. We can have it do anything in our code. This is lighting an LED is just the quickest example for that. Now, the LED that we're using is the one that we soldered onto the board just a minute ago, and we will go ahead and show that and load our code. So let me see if I can make sure that's in the frame. And then let me get my code up. so this is the code that we want to copy. And then we'll go to our MOO editor and we will open up the serial monitor while we do this so that we can see it copy. And I'm going to delete what's there, which I didn't get all of it. And then we're going to paste. And then once it looks good, I'll hit save. And now we can see it saved it, and all of a sudden I see my touch values already, even though I'm not touching the board. It's showing me the touch values that it's getting just as raw values. And so in this, if I want to go ahead and touch that wire, we will see, let me see if I can do it to where you can see it. We can see it lights up the LED, and you can see the touch values jumped up over 4,000, and when I let go, the LED goes off. And so this is our code working. So you can see where you could use something like this capacitive touch to control a lot of different things. All right, let's take a look at our next code. All right, so for our last piece of code that we're going to go through in this lab, what we're going to do is take the code that we used a couple minutes ago for color cycling the dot star LED, and we're going to modify that code just a little bit to work with the touch sensor. So we're going to add the touch IO library to it. We're going to have the touch object on analog pin A0. We're going to read the value of the touch object, and then we're going to do a conditional statement. But for that conditional statement, we will wrap that around whether we iterate the LED or not, whether we actually change that value of I. Let me show you the code a little more clearly. So before in this code, we had this piece to import the dot star library, which we still need. And now we have the touch IO piece. We have all of our comments about what it is we're assigning here, but we assign the dot star using the data, the clock, the number of pixels, and the brightness. And then we assign our touch pin as A0. We do our function. This is our wheel function, where it's going to take in a number and then it's going to spit out a list of red, green, blue values. We're going to set our value for I, the iteration variable, as 0. We're going to read in our touch value and print it out and set the dot 0 to be the function, which includes I here as it goes up there. And then here's the part that's different. If the touch value is greater than 3500, well, then I'm going to print it was touched and I'm going to cycle the color. And it's only at that point that I'm going to make I equal to I plus 1 and iterate it to the next color in the series. And then I'll keep checking time. And you'll notice there's no else here. It's just the if, and it's the indentation that is making sure that this I equals line is under that conditional if. And then time is not part of the conditional if. That's outside of that. So that's why indentation is very important in Python. And so what we're going to do is we're going to put this code on our board, and then we will see how that looks. Okay, and now let's open up the serial and save. All right, so let me actually move this over so we can see it. So we have our LED is right now solid green, and I'm going to press and hold the touch pin, and we can see it's going through the color cycle. And we can see the touch values being displayed in the serial as I do this. So it's going through blue, and then a blue-green, and then it's green, and now there's yellow in there. But when I let go, it's going to sit there and keep that value that it's at until I touch it again. And only when I touch it will it iterate that variable. Otherwise, it stays exactly where it was. And so that is a cool way to incorporate touch into a color cycling of a variable or something like that. Okay, and with that, that is the end of Lab 5. Thank you so much for attending. The slide deck is available at altbeer.us/CircuitPython. And then the code will be available on the GitHub page listed there, and will be linked in where the video is. Thanks a lot, and we hope to see you in the next video.